Hey guys, welcome to your next algebra lesson on solving quadratic verbal problems involving area and perimeter this time. So, since the newest thing is perimeter, we're going to write down what that formula is for perimeter. So, the perimeter of a shape is the distance around that shape, and we're always talking about rectangles in these scenarios. So, if you look at a rectangle, you know that you have opposite sides that are equal. So you will have, typically we call the longer side L for length and the shorter side W for width. And if you're looking to find the perimeter, you're figuring out the distance around that shape. So you're going to want to add all of those sides together. And when you do that and you combine like terms, you'll end up with the perimeter formula, which will turn into 2L plus 2W. So that's a formula that you're going to want to memorize, but if you can't memorize it right off the bat, I think it's helpful to draw the picture and see the visual come to life. And then the area formula, which is the space inside of an object or a shape, would always be, in the case of a rectangle, length times your width. Okay, so those are the two formulas that we'll need to know. And then on top of that, we will want to write down the quadratic formula eventually. But the first question that we have is the perimeter of a rectangle is 82 feet. The area of this rectangle is 364 square feet. What's the length of the longer side? So, before we dissect the word problem into our equations, we always start with let statements so that we can define the variables and give them meaning. So we're talking about the sides, and we're always going to use L and W. It's just easier if we all stay consistent. So L will be the length, W will represent the width, and now we can decode this word problem and set up our equations. So the first sentence, the perimeter of a rectangle is 82 feet, is going to be our first equation. Now, perimeter formula, we wrote up top, was 2L plus 2W. And instead of saying it equals P, we know that the perimeter in this scenario is 82. Remember, is turns into equals. So, our first equation will be 2L plus 2W equals 82. And then the second sentence, the area of this rectangle is 364 square feet, will be our other equation. And we know the area formula is L times W equals 364. And now that we have our two equations, we're going to figure out a way to merge them together. Now, it's up to you to decide which equation you find easier to work with to get either L or W alone. But in my opinion, I always pick the linear equation, because if I try to get L or W alone in the length times width equation, I'm going to end up with a fraction. And I know a lot of you don't like to work with fractions, so let's focus on the 2L plus 2W, the perimeter formula. And let's try to get either L or W alone. It doesn't really matter. I'm probably just going to get W alone. So, when I get W alone, if I subtract 2L from both sides, I'm going to end up with 2W equals 82 minus 2L, and since W is not completely alone yet, I have to do one more step. I need to divide every term by 2, and now I'll have W alone. It's going to be W equals 41 minus L. And now I can merge the two together using the substitution property where I take this 41 minus L and I'm allowed to substitute it in to the equation I haven't used yet in for W. So I will end up with L times 41 minus L equals 364. Okay, we're running out of space. I definitely can't work the rest of this problem out on this page anyways, so if you need more time to write things down, you might want to pause the video now before I go on to a new page. Okay, so to simplify this equation, let's distribute the L, and we'll end up with 41L minus L squared equals 364. Now, I always want my x squared term, in this case my L squared term, to be positive. Since it's negative, I'm going to add L squared to the opposite side, and in the same step I can subtract 41L, because in order to work with quadratics, you always want them to start with set equal to 0. So when I move everything to one side, I'll end up with L squared minus 41L plus 364 equals 0. Now that it's finally set equal to 0, I can use the quadratic formula and solve for my length. And if we have forgotten the quadratic formula, we're going to write it off to the side, which is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So to start off solving this, I need to figure out what's a, what's b, and what is c. Now, if you don't like the quadratic formula, you could try to factor this. It might take a while to figure out what multiplies to 364 and adds to negative 41, but you could do it. This one is factorable. I just figured we'd need more practice with the quadratic formula, so that's what I'm going to stick with for this. So, a is always the number in front of your squared term, so a is going to be 1. B is always the number in front of your variable, so b is negative 41. And c is the number at the very end, not attached to any letter. 364 is what c is going to be. Now before we start off with the typical x equals, we have to look at our variable, because our variable is not x in this scenario, it's L. So our equation has to start with L equals. Then we have negative b. Now because my b is already negative, negative, negative turns positive, so that's going to be a positive 41 plus or minus the square root of, always put your squared term in parentheses, your b is negative 41 squared minus 4 times your a value 1 times your c value 364 all divided by 2 times your a value of 1. Step 2 in this process of using the quadratic formula is you write everything down except for what's inside of the radical, so that in your next step you can find that discriminant, which again is the number that exists inside of the radical, and you can do this by typing into your calculator in parentheses negative 41 squared minus 4 times 1 times 364, and you should get an answer of 225. Now if you remember from your perfect square list, 225 is a perfect square, and it turns into 15. So you're going to end up with 41 plus 15 all over 2, or the other option, because again, this plus or minus gives you the two options, the other option would be 41 minus 15 all over 2. So, when we add 41 and 15 together to get 56, and then we divide that 56 by 2, we're going to end up with a length of 28, and remember the units were feet. And the other alternative, 41 minus 15, would give me 26, and 26 divided by 2 would give me a length of 13 feet. And if I look back to the original word problem, it's asking me what is the length of the longer side. So the one that I care about is the longer side, so the longer side of this rectangle is going to be 28 feet. The nice thing is that when you get two positive answers, you don't need to plug in to find the width. You've actually already found it. So 28 feet, we always usually say the longer side is the length. 28 feet would be the length, and then the width would be 13 feet. So that's nice, you found both anyways, but this question only asked about the longer length side, and that's why we chose the 28 feet. Okay, question 2. The area of a rectangle is 52 square centimeters. Find its perimeter when the length is one more than 3 times its width. So we're talking about length and width, so we'll start with our glorious let statements. So let L equal the length, and let W represent the width. Now, at the very end of this, we have to make sure that we answer the question, because it's saying find its perimeter, and we're going to find that, but first we have to find the length and width of this particular rectangle. So it starts by giving us the fact that the area of a rectangle is 52 square centimeters. So if you remember, the area formula is length times width. We'll start our first equation with L times W equals 52. Then we have the length is one more than 3 times its width. Remember, the word is vital because is an equal sign. So on the left side of that equal sign is the word length, and we said length is L. On the right side of the equal sign of the is one more than 3 times its width. Well, one more than means to add 1, and 3 times its width means to multiply its width W by 3, and we also have the plus 1. Now that we have our two equations, we can merge them together using substitution. And since the bottom equation already has a variable alone, we can start right away by substituting this 3W plus 1 in for L. So when you substitute 3W plus 1 in for L in the other equation, it's going to look like 3W plus 1 times W equals 52. The next step will be to distribute that W to each term. So you're going to end up with 3W squared plus W equals 52. And we always want to set these quadratics equal to 0. We want the a squared value, the ax squared value, or in this case, the w squared value, positive. So we are going to move the 52 to the other side by subtracting. And we are going to end up with 3w squared plus w minus 52 equals 0. And we are going to use the quadratic formula again because that works every single time. So we'll start by writing what is A, what is B, and what is C. Now A is going to be the 3, B is going to be 1, and C is going to be negative 52. And we're going to plug those values into our formula. For the quadratic formula, we'll write it again. It's x equals negative b plus or minus the square root of b squared minus 4 times a times c all divided by 2a. If you need more time to copy anything on this page, pause the video now because I have to go to a new page to continue this problem. Okay, so we are going to plug these values into our quadratic formula. Instead of starting with x equals like we normally would, this one has to start with w equals, because that's our variable, and it always starts with negative b, so we're going to have a negative 1 plus or minus the square root of our b value squared minus 4 times our a value 3 times our c value negative 52 all divided by 2 times our a value of 3. In the next step, we are going to write everything down except for the number inside the radical so that we can figure out what is that discriminant, what is that number inside of the radical. We're going to do that by typing into our calculator in parentheses 1 squared minus 4 times 3 times negative 52, and we should get the number 625. Now, the square root of 625, luckily that is also a perfect square, and that's going to turn into 25. So, we're going to end up with two options here. One will be negative 1 plus 25, all divided by 6. Remember, this plus or minus again allows us to get the two options. The other would be negative 1 minus 25, all divided by 6. So if we simplify this, negative 1 plus 25 will give us 24. 24 divided by 6 will give us an answer of 4. And remember, the units are important. We're talking about centimeters in this scenario. Negative 1 minus 25 will be negative 26. Negative 26 divided by 6 gives us a negative answer of 4.3 repeating. However, whenever you're dealing with length and width, you never want a negative answer because it doesn't make any sense. You can't have a negative length or a width of something. So you just do one line through the equal sign because we are rejecting that negative answer. And if we think about and we go back to what the question asked, it says find its perimeter. Okay, so in order to find the perimeter, we need to find the length and width first. Right now, we know that the width is 4 centimeters. And if we look back at these formulas, our length formula was equal to 3w plus 1. So we're going to use that. L equals 3 times our w, which we found to be 4, plus 1. Now that's going to give us a length of 12 plus 1, so 13 centimeters. And if we figure out the perimeter of the shape that is 13 by 4 centimeters, we can plug those values into the perimeter formula, 2L plus 2W, so 2 times 13 plus 2 times 4, and our perimeter should be 26 plus 8, which would give us a perimeter of 34 centimeters. And that is the final answer of this particular word problem. And that's going to end our notes for today.